Hi, in this video, we're going to look at how to use central difference approximation methods and what is that actually used for. So let's think about the concept of the central difference approximation. Now, think about I have a original curve. Okay, let's call that f of x. Now, at the point somewhere here, x. So let's call this point x and f of x, right? I'm going to draw a tangent graph, tangent curve, passing like that. And I want to know what is the gradient of this tangent. Okay. So how do I get the idea? What I do is you can see there's a point that's very close to this point on the left-hand side. So I'm going to pick one point that very close to that and lie on f of x, but not exactly on the tangent, but very close. So here. So this point you can see because we're talking about this is x here, right? And because the point on the left and the gap is very small. So let's call that gap h. So we're going to call that at x minus h. Okay. So here I'm going to have here x minus h and the y value is f of x minus h. And then similarly, I'm going to pick a point on the right-hand side that's very close to the red point, but this time I'm going to do plus h instead. So there's an equal gap in between them. So this point here will be x plus h, and then f of x plus h. All right. Now, and imagine, so those 3 points are at the moment different, so but they're very close, right? Now, if I want to find the gradient of a tangent, this means that tangent only touch the curve at one point. So for those 3 points, to be lie on f and also on the tangent, the only possibility that could happen is those 3 points are identical. This means that h have to be 0. This means you don't have any gap in between those 3 points. Yeah. And if you think about the gradient of the the green point and the black point. So the black point x plus h, fx plus h, and the green point is x minus h and fx minus h. So the gradients in general term is f of x plus h. So y2 minus y1. So fx plus h minus f of x minus h. So I'm talking about the point on the left and the point on the right. Okay, I'm finding the gradient of that point over x2 minus x1, so x plus h minus x minus h. All right. So what you can see here is x minus x cancel out. H minus h, you would have 2h on the bottom. And then on the top, you would have f of x plus h minus f of x minus h. Okay, so this is the gradient in general concept. And we talk about if we want that to be the gradient of a tangent, those 3 points must be identical. And because they're identical, h will need to be 0. So that's where we do limit of h approaching 0. So this is called finding the gradient, finding the derivative using central difference approximation. That's the name of a central difference approximation. So generally the formula is just that formula right there. Now I'm going to give you an example and I'm going to show you how to use the method. So let's say finding the derivative of y equal x squared minus 4x, something like that. And I want you to use the central different methods. Now, because this question, they specifically want you to do this method, but you know that by normal derivative, you could have guessed the answer. The answer derivative of that will be derivative x squared 2x, and derivative of 4 is 4. for x is 4. So you know the answer, but we want you to do this method. Okay, so let's get started. So based on the formula say mt, or the derivative, will be equal lim of h approaching 0, f of x plus h minus f of x minus h over 2h. That's the formula for central difference, as you can see here. Now I'm going to sub it in, okay? So f of x plus h is where you substitute letter x with letter x plus h. So you're going to write that as x plus h squared, okay, minus 4 times x plus h, like that. So this represents fx plus h, and then you do a minus. F of x minus h will be doing the same thing, but you replace f minus h instead. So you would have x minus h squared minus 4 times x minus h, like that. And then you do that over 2h. Okay, now all I have to do is just simplify the whole thing here, which is a bit expansion. So lim of h approaching 0, x plus h squared is x squared plus 2xh plus h squared. And you're going to expand this one out, which is minus 4x minus 4h. Okay, then you do minus, then I do the whole thing inside. Yeah. So x minus h squared will be x squared minus 2xh plus h squared. And then you expand this out as minus 4x plus 4h, and then close bracket, right, over 2h. Okay, now let's look for slight term simplified. X squared minus x squared go away. H squared minus h squared go away. Negative 4x minus negative 4x also go away. So now if you look at this one, 2x minus negative 2x will be 4x, and then negative 4h minus 4h is negative 8h over 2h. Okay, I still keep the limit outside. Then what I do next is I simplify. So you can see they both have h on the top and the bottom, and they both have 4a2. So what I do, I just simplify by taking out the common factor on the top. So I have 2h. Take it out, so you have 2x left, minus ah divided by 2h is 4 over 2h. So 2h and 2h go away. What you left with is just 2x minus 4. And h equals 0, you can't substitute anywhere there. So there you go. That's the answer for this question. And then we said earlier, we can clearly see the answer from here if we just use the derivative formula, derivative of x squared 2x, and derivative of minus 4x is minus 4, which is exactly what we got. But in some question, they want you to apply the specific methods.